Bismillah ar-Rahman ar-Rahim. Today we are going to speak about the trapezoidal rule. First of all, let's define what is the trapezoidal rule. This rule is just a numerical technique or approximation to find some approximate value for some integrations. In some cases, the integration is not easy to evaluate or to find the exact solution. So we are looking for some approximation. And these kind of approximations applied using some numerical approximation. Trapezoidal rule is one of them. We have different type of techniques. Trapezoidal, Simpson, right corner, left corner, midpoint. So let's define this technique to find some approximation for some integral problems. For the trapezoidal rule, suppose that we need to find the integration or definite integral or a function from A to B. Suppose that we have continuous function f of x defined on an interval A to B. This is f of x. So we need to find the integration A to B f of x dx. If the function f of x is not easy to evaluate or to find the integration, and we need to approximate it, we will just partition the interval A and B to sub-intervals. It will be with equidistance. And we construct trapezoids. And find the area for each one of these trapezoids. We know that the area of the trapezoid is equal to B1 plus B2 divided by 2 multiplied by h. If I have like this, the bases are the parallel lines or parallel sides. So the area is B1 plus B2 divided by h. And we use this to be h. The subintervals, or all of them are equidistant. Now the points of these A, I will call it x sub 0. Then plus h each time to find the next point. So xi to A plus I h, where I start from 1 up to n. N is the number of the subintervals. And now this integration f of x dx can be written as h divided by 2 multiplied by y0 plus 2 y1 plus 2 y2 up to y n minus 1 plus yn. Y sub 0, y1, y2, these are the values of the function at the point of the partitions at xi. And h is out. H is equal to b minus a divided by n. As I mentioned before, n is the number of the subintervals between a and b, number of the partitions. So this is the trapezoidal rule. It is h divided by 2 multiplied by y1, y sub 0 plus 2, y1 plus 2, y2 up to y sub n. This is y sub 0, which is equal to f at a. And the last one is yn, which is equal to f at b. This is yi, which is equal to f at xi. And xi can be found by a plus I multiplied by h. H is equal to b minus a divided by n. Let's give an example to explain this idea. Use or approximate the given integral using trapezoidal rule. T10. T10, the number 10 given there, sub 10, is the number 10 is the number of the subinterval or the partition. So for this example, we have n equal to 10. So with that, I need to approximate the integration 1 to 2, 1 over x dx. This is just an example to explain the concept. It is easy to find the exact integration for, or exact value for this one. It will be ln of 2. But I want to use the trapezoid rule or trapezoidal rule to just explain the idea. We can use different type of examples. Now for this one, we have n equal to 10. So h is equal to b minus a divided by n, which is b is equal to 2 and a equal to 1. So this is 2 minus 1 divided by 10 equal to 0.1. This is h. So xi will be a plus ih, which is equal to 1 plus I multiplied by 0.1. So let's write these values and find the approximation for this integral. We have I, we have xi, we have yi, and we have the coefficients, the weight and weight multiplied by yi. For the I, we start with 0 up to n. So 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We must have 10 to be the last one. X sub 10, which is that will be b. When I equal to 0, x sub 0 will be a, is equal to 1. Then we add 1h each time. So the next one will be 1.1. Next one will be 1.2. We add h each time. We know that h is equal to 0.1. So we add 1h each time. Next will be 1.3, 1.4, 1.5, 1.6. Just add one each time. 1.7, 1.8, 1.9, and 2. See, the first one is equal to A, last one is equal to B. You must have, the last point must be equal to B, which is 2, the upper limit of the integral. Now the function f of x equal to 1 over x. We go back, this is my function, 1 over x. So we are using this function to find the values of the function on y, I. The first one, we replace x by 1. So it is 1 over 1. That will be 1. Replace x by 1. For the second one, we replace x by 1.1. 1 divided by 1.1 will be 0.9091. Find up to 4 decimal points. Up to 4 decimal points. I'm going to find up to 4 decimal points. Just only 4 digits after the decimal point. Now, if it is 1.2, divided by 1.2, you will have 1 point or 0.8333. If it is 1.3, the value 1 over 1.3 is 0.7692. Use the calculator to find these values. If it is 1.4, I will have 0.7143. If it is 1.5, will be 0.6667. If it is 1.6, will be 0.06250. If it is 1.7, we'll have 1 or 0.5882. If it is 1.8, will be 0.5556. If it is 1.9, will be 0.5263. And if it is 2, will be 0.5000. So these are the values of the function at the partition points, xi's. Now for the weight, omega or w, we start, the first coefficient is equal to 1, the last one is equal to 1. The others will be 2, all of them. These are the coefficients in the rule. It is 1 for the first one, 1 for the last one, and all the others will be 2. Now multiply the value with yi. The first one will give me only 1. 1 times 1 is equal to 1. Next one is 1.8182. Next one will be 1.666, and that will be also 6. Next one, 2 multiplied by 0.769 will be 1.5384. Next one will be 1.4286. Next one will be 1.3334. Multiply the next one will be 1.2450. It is 1.6 or it is only 1.25. So about this one, 250. For the next one, it is 1.7. I will have 1.7 or 17. 1764. It is 5, or when it is 1.8, we will have 1.1111, and next one it will be 1.0526. The last one is 0.5000. Now for the next point, just add all of these, find the sum. If you add these values, you'll find the total for this one, for the last column, is equal to 13.8754. Just add the last column. It will be 13.8754. Now the integration 1 to 2 of the function 1 over x dx is approximated by t10, which is equal to h divided by 2 multiplied by the total, the one that we found in the last step. H is equal to 0.1 divided by 2 multiplied by 13.8754. And this will give me 0.1 multiplied by 2, that will be 0.6937. So this is the approximation for the integral 1 to 2 of 1 over x dx. If we want to find the exact solution, because for this function it is easy to find the exact solution. If it is not possible, we will not find it, but for this example, just to compare between the two values. The exact solution. Integration 1 to 2, 1 over x dx equal to ln x1 to 2, that will be ln 2, which is equal to 0.693147, and you can see the two values are close to each other. The first 3 digits are matching. The only difference is in the fourth one. And it is known that the trapezoidal rule is accurate up to 10 to the power minus 3. The 3 digits are matching, and that will be enough for approximating the value of some integrations. So this is the idea of the trapezoidal rule. It is just a numerical method to approximate some integration when it is not possible to find the exact one. If it is not possible to find the exact one, we are using some approximation techniques to find the approximate values.